Hello everyone, this is Thiago Alves, and that's our second video on the OpenPLC V4 Tour series. For this video, we're going to dive into the Irrigation Controller. This is the coding part, so we're actually going to implement the code inside each one of the function blocks that we created on the previous video. Now let's dive in. So this is where we stopped on the last video. We created a bunch of function blocks to design our irrigation controller. And again, just a note to everyone, this is not the ideal irrigation system. The purpose of this video is actually to demonstrate the capabilities of the OpenPLC Editor. So we're actually going a little bit beyond of just adding, some logic on irrigation systems. The idea is to create a bunch of different blocks and program them using different languages and demonstrate, the capability of the editor of handling different languages in more complex projects with large, data and more variables, different custom data types and things like that. So we're kind of exaggerating on the complexity of the project, but this is just to demonstrate what kind of project we can build using the new OpenPLC editor. All right, so let's start with the irrigation main controller. So this is the main point of our system. That's what actually is going to control the state of our entire irrigation system. And we decided to create this using ladder logic, right? So right now our project is blank for the controller. I'll go ahead and expand the table. We don't have much here. All we have is the state. And just to recap, our state is a custom data type that can be either stopped, running, or manual. Now, the first thing we got to do on our system is to actually verify, let me put this in a comment, if we are in manual mode, right? And to verify if we're in manual mode, basically all I have to do is to compare if the state is equal to manual, right? That would be really simple by using one of these equate blocks here, right? I can just say, hey, if equal state manual, then I take action. But unfortunately, that does not work, because when we pass this along to the compiler, it's going to complain because it doesn't know what state compares to. Because state is a custom type that we defined. We defined this type as stopped, running, and manual. So the compiler doesn't know how to compare a custom type with a custom type. So we have to define ourselves our own block to calculate how things are equal or different, right? So let me take this out, and I'll create a function. That's all we need. It doesn't have to be a function block. It's just a function, and I'll say this is an equal state, and I'll do this in structured text, right? So this is a block just to determine how I can compare two states, two irrigation states, right? And for this block, I only need state 1, that's one of the inputs, and this obviously is of irrigation state type, and state 2. So I'm receiving two states and I'm comparing if both of them are equal. And I don't need an output because the function is an output by itself, and it's going to return a Boolean, right? So a function always returns something. So all I have to do is to say if state 1 is equal to state 2, and that is okay to compare, right? So they both have the same value inside. Then I'll just say equal state, that's the name of the function. What's gonna return, I'm gonna say that this is true, right? Because the two states are equal. Else, I'll say EQ state false and if. That's it. That's all I have to do on my equal state to compare these two states. Now that I have this block ready, I can use the block here in my program. I have it here on the user-defined POUs, and I can just drag it here. All right, Now it prompts me for the two states to compare. And I can say state, that's the state that I have on my system already. And I'll compare this with manual, right? This is a constant. That's why it's colored yellow, as I explained on the previous video. And then I'll trigger this, I'll put the result of this operation into a variable. Let me call this man mode, like for manual mode. So this basically tells us that we are running in manual mode. That's all I need to know. All right, next thing we need to do is to actually control our irrigation valve. So to control the valve, I must make sure that I'm not in manual mode. So I'm adding a contact that is negated. So this logic only runs if I'm not in manual mode. And I add another contact that represents our moisture, the moisture sensor, right? And so if the moisture sensor is true, saying that I'm low on moisture, and I'm adding another contact here. If you remember, we have the Tmax variable as one of our inputs. So basically is if I haven't ran more than I determined as the Tmax, right? So this is my timeout. Let's call it a timeout variable. And this is also negated. So I haven't reached my timeout, then I will run the valve. Let's call it run valve at this as a variable. So this logic is pretty simple. This thing means I'm not in manual mode. The moisture sensor is telling me that I'm too dry, and I haven't ran up until my timeout, right? But that's determined by the Tmax that we're gonna put the logic further. Then I can run the valve. If either one of these two, either the manual mode is true or the timeout is true, I cannot run the valve even if the moisture sensor saying that I'm too dry. All right, pretty simple. Let me add a comment here. I'll put control of the irrigation valve. That's all we need to know. All right, now let's add another rung. And while we are adding rungs here, it's interesting to note that this new version of the ladder logic editor is much improved when compared to the previous version. I can just drag and drop elements, as you can see that I'm doing right now, and I can also rearrange rungs, right? Put it in different orders. This is a feature that many people requested from the previous editor. After you've added a bunch of code in your diagram and you want to add something in between two rungs, it was really difficult. You had to select all the elements, create space, and add, elements in between. Now all you have to do is just click on a button to create a new rung and then position it in the place you need. And if you want to delete a rung, just click on the X here and it's gone. The other thing that is pretty cool about this editor is we have this duplicate button. If you click on this button, you'll just create another rung just like that one, right? So if you have some logic that is repeating, have a very similar logic with different variables, this is very useful. You can just duplicate rungs and start doing your modifications on the duplicated one. So this is pretty cool. And the last feature that I also love on this editor is to hide rungs. So when you have a lot of code and you want to focus only on the thing that really matters, you can just go and hide everything, leave only the code that you're focusing at, so your screen is not bloated with a bunch of things that you don't care. So this is pretty cool, helps a lot when designing complex diagrams. All right, so going back to this, we've already defined the logic to run the valve. Now we need to create the logic for the timeout. Remember, the timeout is associated with the Tmax time, so I receive this as the maximum time that I can let my valve to run. So this is to prevent if the moisture sensor is damaged or if it's just extremely dry, I don't run my irrigation system for extended periods of time, for 10 hours, 12, 20 hours, right? So I can determine whatever the maximum time it is. And to create this logic, that is pretty simple. It's kind of like a blinky circuit. All I have to do is to put a contact here, and I will associate this with the run valve. So my valve is running, and I put a timer in front of it. put a T on. So this timer will basically count the time that this valve is running. And what time is that? That's gonna be T max, right? So when the valve runs for that T max amount of time, I need to shut down or toggle my timeout. That will essentially shut down the valve. But if I just put the timeout here like that, I'll get into a problem because this will basically toggle the timeout, and this will turn off the valve, and this will essentially reset my timer. So I'll just have one cycle of timeout, and then the count will start again. This doesn't work for what I really need. I need to hold that timeout on for a certain period of time. And the best way to hold it on is to actually put a T off timer. Right? So the minute this T on timer fires, it's gonna, activate this T off timer, and then even after this timeout is activated, it will turn off the valve and turn off T on. The T off will hold this timeout true for a certain time. And what time is that? Again, I'm putting T max. So basically, when you reach your maximum running time, the system will shut off for the T max amount of time. So whatever time you determine to be the maximum time will be the same off time. The time the system will be shut down to rest or to recover. Right? So this is our logic for, let's call it a determine if we had ran for too long. Right? So this is the logic we need for the timeout. Very simple. Now, finally, because our system works in states, right? I have this run valve here that internally tells me if I need to run the valve or not. But again, this run valve is a local variable to the block. It's not to the whole system. So if I maintain it locally, the system doesn't know, like the system outside of this block doesn't know if I really need to run the valve or not. So going back to our ladder logic, I need to set the state of the system to actually determine if I want to run the valve or not. Now, to set the state, again, I cannot just simply use a move block to move state from one place to the other, because I have the state as a custom data type. So I need to inform how to manipulate that custom data type. And to set a state on a custom data type, we already created the code to do that on the previous video, right? We did this in structured text, and this is a very simple function. All it does is it receives a state and it spits out the state that it received, right? So it's just like a move block, but it was coded in structured text. All right, so we're gonna use the set state block that we created. And we need to activate the switch state on a condition, and this condition is connected to the enable block of the set state block, right? So what is the condition to set state to running? So what is the condition? The condition is that I have my a contact here that is my run valve. So my run valve is true, and I'm not in manual mode, because if I'm in manual mode, I cannot change states, right? I'm not in control. So if I'm not in manual mode and the run valve is true, I'm allowed to set my state to running. This is the state, right? So that's all it does, is set the state to running given the condition of the valve that is activated, right? And again, running is one of the options here for my irrigation state data type, all right? Very simple. I'll do now the same thing for the stopped state. So let me type here set state to stopped, and I'll use my set state block. Again, I'll just put stopped to state. Very simple, just to make sure that I'm using the right spelling. If I misspell this, obviously it's gonna give me a compilation error. And now the condition to stop, right, to have the state move to stopped, is that my valve is not running, so valve is not true, and I'm not in manual mode, right? That's it. So I guess that's basically all the logic we need on our irrigation main controller. We have everything we need. We're comparing the state to know if we're in manual mode. If we're in manual mode, we basically don't do anything, right? We can't even change the states here. Now, if we're not in manual mode, then I'll determine if I should run the valve or not based on my moisture sensor and my timeout. If I have ran the valve for too long, I'm going to toggle the timeout that will shut down the valve, right? And now finally, I'll determine the state based on the run valve state. If the run valve is true and I'm not in manual mode, the state is running. If the run valve is false and I'm not in manual mode, the state is stopped. Very simple. So we have the irrigation done. Now, the next piece of our puzzle, if we see the whole picture here, we have the irrigation main controller, the state of the system, the sensor, moisture sensor here, the maximum time connected here. The next piece of the puzzle is actually to display, the state of the system. And we decided to do the state display in instruction list. Now, I guess we have a problem here. Instruction list is a very primitive language, and the compiler only works with primitive data types. So for our irrigation main controller, going back here to the main program, we spit out a state as a custom irrigation state. And when we start trying to write code here on the state display in instruction list, I cannot do any comparisons or any operations really with the state because it's a custom data type. And it's really hard to work with custom data types on instruction list. So what I'm going to do, I'm going to cheat a little bit, just a little bit. I'm going to create another function called state to num. And all it's going to do, it's actually going to take my state and convert this to an integer. And that will make it much better for my state displays written in instruction list, right? So I'll just remove this connection here. And I'll also remove the state display from here. And on the state display, I'm going to change the input state here from irrigation state to be integer. So this is a base type. It's much easier to work on instruction list if we have a base type, right? And then I'm going to create a function that is going to be state to num. So it's converting my state to a number. And that is going to be written in structured text as well. And this function is very simple. The return type for that function is integer. So it's going to return an int. And the only input it receives is the state. And that obviously is of type irrigation state. So what is the code for this? Very simple. If state is stopped, then I say state to num is 0. So I determine a number here. Stopped is 0, right? Now I can say else if, and now I'm taking advantage of the autocomplete here. This is one of the features that I'm really excited about the new editor. If you haven't noticed yet, our structured text editor is actually based on Visual Studio Code. So you have, all the nice features that Visual Studio Code has to offer in PLC programming language. And this is mind-blowing. It makes everything so much simpler, and it's so much more powerful than the previous iteration we had. All right, so for example here, we just compared the state to stopped, but then we can also say if its state is running, then state to num, state to num, it already gives me here is 1. And obviously I can also copy paste things. I can do this again here. And if my state is manual, then state to num is 2. And that's it. I can finish my block here, and if. Right, very straightforward. I'm just comparing the state to different states and determine a number. To be safe, if I'm just using these three and suppose I add a different, state here, I include another one like error or something, this function will just fail to return the correct value. So what I could do, for example, is put an else here. That would be the default state, right? State to num receives, well, I could say it's 3 or 4, any number I really want. So basically, if it fails to compare to any one of these three, it's finally defaulting to 3. All right, so we have our state to num block. Going back to our main diagram here, I'm gonna add the state display back, and I'll probably need to give some space, some extra space to this. I'm gonna connect the LEDs again, 3 LEDs, but I'm also adding an extra block here that is the state to num, right? And this is feeding my state here, and it's getting the state from the system. All right, very simple. So I get the state converted to a number, and I feed this to the state display. And now I'm ready to program my state display using a plain integer. So what does the code for that look like? Let's start by just saying, what we're gonna do in each one of the states. I'm gonna create labels. So if you're not familiar with instruction list, this language kind of looks like assembly, like machine language. It's a very old language. It was created for engineers that are familiar with this type of low-level programming. So it's still in use in some old projects, legacy projects that still need to be maintained in that kind of algorithm. So for new engineers, that may sound a little overcomplicated for things that you just need to assign a value to a variable. But for old school engineers, people that have dealt with assembly, this has its power and advantages, right? So one of the tricks to work with this type of language is to use labels. So you can jump between labels. So the first thing I'm going to do is to create all the labels for the different LEDs. So let's say we're in a state stopped. This is my label, and you see it colored properly. What I need to do if my state is stopped, I'm loading 1, then I'm storing this 1 into stopped LED, right? And then I'm loading 0, and I'm storing 0 to manual LED, and I'm also storing 0 to running LED. And I also will need to have exit program label that I can jump to. So if I'm in stopped, after I execute these instructions, basically assigning 1 to stop LED and 0 to the others, I'll just jump to exit program. Done. Right? So I'll do the same thing with my state running. And that basically is the same code. I'm just going to copy here, but with different variables. So I'm loading 1 to the running LED, and I'm loading 0 to the stopped LED, right? And finally, the last thing I need to do is put the manual one. So state manual. I'm gonna copy the code again. Loading 1 to the manual LED and loading 0 to the stopped LED. Right? So I'm loading 0 to all the others, loading 1 to manual. Okay, I created all the 3 conditions that determine, if we're stopped, running, or manual. And all the 3 blocks jump to the exit that is pretty much blank. I don't do anything else when I'm exiting. Now, the first part of it is to determine which one of these labels I should jump to. So this is the determine state phase of my program. So how can I determine the state? Well, first I load state into the accumulator. So this is the variable, is an integer. And then I compare that with 0, right? And if you remember, on my state to num, 0 means stopped, right? So if I compare that to 0 and the comparison is true, I mean the value on the stack is true, I'm gonna jump to state stopped. So the code will just jump from here to here, execute whatever is in the state stopped, and then exit, right? So this is how to determine if I am in the 0 stopped state. Now I load state again, and I compare that to 1, and going back to the state to num, 1 means running. So I'll just jump, conditionally jump if the comparison is true, to state running, right? And finally, I'll load state again. Oops, my autocomplete failed me. There we go. We'll load state again, and I'll compare that to 2 and conditionally jump to state manual. That's the last state I had. And in the end, I'll just jump to exit just to be safe, right? If any of the conditions, if none of the conditions are true, I'll just exit without doing anything. That's it. It's a simple logic. It looks like a lot just because, instruction list takes in a lot of mnemonics, and it's a different way of wiring your brain, but it's definitely interesting, and it's worth exploring as well. So the instruction list editor on the new OpenPLC editor was built using the same technology as the structured text editor, right? So it's also running on Visual Studio Code, and you also have the same features, the same stuff that you would find on the modern Visual Studio Code, even if you're programming an ancient language like instruction list. Very cool. So we're done with that. Going back to our main diagram here. So we covered the irrigation main controller, the state display, and it's now displaying all the LEDs and converting that to a number. Now we need to explore the manual override, and the manual override basically is overriding. If we are in the manual state, we need to turn the valve on or off based on this manual valve Boolean variable here, right? And we already handled the set manual control and automatic control outside on the FBD block, so we don't have to worry about that here on this block. So the code for this will be fairly straightforward. We already have everything we need in terms of variables. So all we have to do is compare. If state is manual, then I do valve, that's one of the outputs here. Valve is equal to manual control. So basically whatever manual control says, valve does, right? This is if we are in the manual state. For operations like this, structured text shines. It's very easy to write, logic and complex math and, some logic operations, state machines. It's really easy to write things like that in structured text. It basically tells a story, and it's quite verbose in the way it's telling it. You don't have to include like parentheses or any other symbols like C++, languages like that. You need to include a lot of extra symbols. So this is all we have to do. State manual, valve receives manual control. Now, if we are in our state is stopped, then I need to do something else. My valve will be false. Oops. And finally, if the state is running, my valve is true. So I'm telling the valve to follow the state of the system, except when it's manual. So when it's manual, the valve will follow the, whatever manual control determines. And that's it. That's all we have to add here to our manual override block. I guess that concludes our entire system. We have everything we need. So going back to our main program, just expanding the view here a little bit so we can zoom in. So the entire code is implemented now, and we have also the state being displayed here on the LEDs. Now the next step is to simulate this and see how it runs. And we're going to do this on our next video. Thank you for watching this. I hope you've enjoyed it, and please subscribe if you haven't. Leave your comments below about what you think about the new editor, and happy coding. Thank you for watching. See you in the next video.